I should double check. Yep. So it's recording. If I look at the recording tab and it's actually doing all that wave stuff, that means it's recording correctly. All right. So we got that out of the way. It is recording. The browser is up. This is from my previous class. It's really kind of cool. For those of you who like to actually do some coding and see the code work, but you don't want to learn the syntax and have to deal with syntax and compilers and stuff like that, I can give you a suggestion maybe a little bit later today. So this is, I'm going to close off, maybe not. I'm just going to go to the lecture for this class. Go. All right, so reading material. Why do I want to learn programming? Basically it's just give you some motivations. And I tried this out last night and it worked out okay. So I will try it out today, and you guys can tell me whether you want it or not. Okay. It's a microphone and the speaker system. There is a speaker over there. And there should be another one somewhere else, maybe not. Oh, there are two speakers next to the projector screen. Testing. Okay, it's not. Well, I guess turning it on may help.
Testing.
Oh, that's kind of loud. Okay, is that okay? Too loud? Too soft? Just about right? Okay. That's good. For people right over there, is it okay, or is it too loud?
What?
Okay, it's good. All right. That's a good answer. I like that. Okay, so we talked about what do I want? Why do I want to learn programming? And I think this is the part that I did not go through last time because we ran out of time. So I'm going to do a preview, go through all the questions, okay, and basically talk about in computer science what is the problem, because this class in its title has problem solving. So what kind of problem are we solving? Okay. In computer science, a problem is expressed as a precondition and a postcondition, which is kind of dry and mathematical and stuff like that. So I'll give you an example. Okay, so I'm skipping some of the stuff here and skip to this particular problem. All right, so we haven't really talked about variables, so just look at this as finding the maximum of two things, okay, two particular numbers, and tell me what is the maximum of those two numbers. Sounds pretty simple. You know how to do it. But can you tell or instruct a computer to do exactly that? That's the question, okay? That's the problem that we are solving. It's not whether we know how to do it. It's can you tell the computer, can you instruct a computer to do exactly that? Okay, that's the kind of problem that we are trying to solve in this class. So when we talk about variables in this case, this is variable not in a programming sense, but in a mathematical sense. Okay, it's a mathematical variable x, a mathematical variable y, and so on. The first thing we need to do is to figure out, but how do we express a precondition and how do we express a postcondition? By the way, what is a precondition? What is a postcondition? So if you think about it, okay, so let's say this stuff here represents the execution of your program, okay? Well, your program has an entry point. When you start the program, you load a file, that's the entry point, right? That's the starting point of the program. The precondition is basically a mathematical expression that says, oh, we know about these things when your program starts. There may be something that we know, there may be nothing that we know. But nonetheless, you have to say what you know when your program starts execution. Postcondition means when your program is all done, this is what we know, okay? Or this is what we want, okay? To be more exact, the postcondition is sometimes what we want, but is the program actually accomplishing that? That is the big question, okay? Because a lot of times we think the program is doing what is correct, but it's not actually doing what is supposed to be done. So the actual postcondition of your program may not be the actual desired postcondition. Is that okay so far? So the problem that we are trying to solve can be expressed by the precondition what you know about stuff before your program executes, and the post condition, which is describing how things should be when your program is done working. So the real problem is, how do we specify the code in your program so it will accomplish this, going from the precondition to the post condition? So are we doing okay so far with the definition of what is the problem that we are solving in the context of computer science, in programming? Okay, very good. So in this case, we're finding the maximum. How do we express the precondition? Given x and y, how do we express the precondition? Nothing, okay? Because we want this algorithm to work with all values of x and y. We don't want to put any constraints onto x and y initially. Okay? So we cannot say, oh, we want to make the assumption that x is greater than y. No, we don't want to make any assumptions whatsoever. What about a post condition? How do we express that the number is the maximum of two other numbers? Well, that's when things get a little bit interesting. Because at first, you might think that we can just use this expression here. M is greater than or equal to x, and m is greater than or equal to y. That makes m the maximum of those two. But that's not true. Because if I give you an example like this, x is 2, y is 4. What is the maximum of 2 and 4? 4, right? But if I say 20, 20 is greater than or equal to 2, 20 is greater than or equal to 4. But yet 20 is not the maximum of 2 and 4, right? Well, that means the highlighted portion of this text here is not a correct description of the end result. It's not a correct description of the post condition. Is that okay? What is it missing? Well, as it turns out, for something to be a maximum, it has to be the same as at least one of the values that it is a maximum of. That's what we were missing. So by putting this extra constraint on top of what we already have, then we have the proper definition of what is the maximum of two variables. Are we kind of doing okay so far with this stuff here? How many people are thinking this is way too much math? I just want to program. I just want to write a game. Okay, you don't have to raise your hand. You can think that way, but you don't have to raise your hand, okay? But a lot of people think that way. Why do I have to understand so much math just to write programs? What do you think? Yeah, go ahead.
Math is the language of computers.
What do computers do?
Compute.
It computes, okay, and computation is related to logic, and logic is a field of mathematics. Exactly, okay? Yep, go ahead.
Math has a lot of the same rules that programming has.
Yes, but there's a good reason why that is the way. Because computer science used to be, and really should still be, a branch of mathematics. Okay, that's the bottom line. Who's Alan Turing? He's the guy who came up with all of the theoretical stuff of computer science. But back in his days, obviously people do not call him a computer scientist because there were no computers before him, right? So what do you think was the description of his expertise? He's a mathematician, exactly, okay? So mathematics is the foundation, is the basis of programs, okay, of programming. All right, so when you are going to give instructions to a computer, this is what we're going to do, okay? A problem is solved by, okay, so how do we specify, how do we tell a computer how to solve a problem? Steps of instructions that the computer can execute. That's kind of a general description of what we want the computers to be able to do, is to follow the description of, what to do, in steps. It is not unlike descriptions of how to do something when you are telling somebody else to do something, okay? So you can, okay, let's say you have a friend over the phone, and the friend tells you, my car won't start, okay? and you are trying to help this friend to diagnose the problem, to find a solution. Okay? What do? Well, you ask a few questions, you get the answer, you analyze, you give your friend a few more steps to perform, and so on, right? It's interactive. Can you do that with a computer when you're programming a computer? Can it be interactive? The computer comes back to you and say, I'm not quite sure what you said about that. Okay? Does the computer come back and clarify? No. So that means you have to get all the instructions right the first time. There's no interaction. Once you're done with the program, it just goes and it executes the instructions. Is that making any sense? So that's basically the second paragraph for those of you who have read it. Okay. Besides ambiguity, which people do all the time, okay, ambiguity means there are several ways to interpret a particular sentence, a particular statement, okay? When you encounter that in your other classes, or even in this class, what do? You raise your hand and you ask, okay, what do you mean by this? Do you mean this, or did you mean that? Okay? Or you can just flat out ask, can you explain this again using a different way? Okay? You can do that when you're interacting with a human, but you cannot do that when you are programming a computer. You cannot afford to have ambiguity when you're programming. Natural language instructions can also be filled with what we call holes. Okay? In other words, you are assuming the other person knows about something that is not true. The other person actually doesn't know about that something. Okay? For instance, if your friend's car would not start, okay, you might give the instruction of, okay, check the voltage of the battery. But your friend may not know what is voltage or how to measure the voltage, of the battery terminal. Well, that's okay, because that assumption turned out not to be true. You can now tell your friend, okay, go take a multimeter, switch it to voltage mode, and the scale is up to 20 volts, and then apply the red probe on the positive terminal and then the black probe on the negative terminal, and then tell me what is the number on the multimeter. Okay, so you can fill in these omissions as you go, because the other person can ask you and say, okay, what do I do now? Okay, can't do that when you're programming a computer. Natural languages are not concise, which means, what does it mean? What is the word? What does it mean when I say something is concise?
Without ambiguity.
Not quite, okay? That's precision. What is concise? What is being concise? Exact, okay? That's kind of precision as well.
Expressing in little words.
Yes, as few words as possible. Spock is concise, because it doesn't say anything other than what is necessary. Bones is not concise. It gives you all kinds of information that is not relevant. Is that okay? Does everybody understand what is concise? Why do we want programming languages to be concise? Sorry?
So the computer can work efficiently.
So the computer can work efficiently? Okay, go ahead.
Less chance for error.
Less chance for error, or just flat out being lazy. I don't want to type. Okay? Go ahead.
Easy to navigate and edit.
Easier to review a program because there's not a lot of stuff in it. Okay, very good. So those are all good reasons why we want a programming language to be concise. But with concise programming languages comes a problem. They're more difficult to read. Okay? So for those of you who want to get an exposure of what is concise and what is not concise in programming, C and C++ are considered fairly concise, and the most verbose programming language that I know of is COBOL, C-O-B-O-L. Okay, so if you just look at a sample of a COBOL program, C-O-B-O-L, program example, okay. And we'll go with sorting and merging, and we'll go with view. That is that's COBOL, and you can see that I'm just going to focus on one particular part, just so that you have a taste of what is kind of verbose. So if you look at the last part here, procedure, division, begin, merge, work file, on ascending key, blah, 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 using blah, 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 giving blah, 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 stop, run. It almost reads like English, okay? Just pretty close. It doesn't make use of a lot of obscure, symbols like open curly brace, open square brackets, semicolon, comma, period, and they all mean different things. Okay? So this is verbose. This is not very concise, but it's more easily read. Okay? When you look at C and C++, which is what you need to do for the next class, that is no longer true. C++, and I'm going to look for obscure programs, okay? Obfuscate. Oh, the worst one is not C and C++. I'm going to go for Perl, okay? So Perl, difficult to read. Okay, there we go. Coding style, what is the most unreadable program? Okay, that's see if anyone has an example here. I would say that's pretty difficult. Okay, let me just kind of magnify this a little bit here. So there's the use of square bracket. Oh, well, I don't know what is the significance of using square bracket. There's a use of $sign, asterisk. Instead of one single equal, there are two equal symbols, right? And then there's the if. There's a phi down here. Doesn't seem to map to any actual English words, right? So that is a good example of not something that is concise, but it's difficult to read. So there's a little balance thing, here, because if something is too concise, it's not going to be easy to read. But if it's easy to read, it's not going to be very concise. Okay. In general, we want things that are concise, but sometimes you kind of have to take a step back and go like, oh, this is way too much. Okay. That's not what we're doing. Just getting back to where we are. Okay, there we go. All right, so next slide talks about algorithm. Okay, so I just discovered this when I looked at the word this semester. I always thought I knew what algorithm means and how we derived the word, but when I looked it up this semester, I found out that it's based on the name of a person who lived in Baghdad from in the 7th century. Okay, I did not know that. Okay, that's new to me. So that's kind of cool. The keyword here include, I also made a little joke here somewhere. Oh, it's in the answer. It's based on the phrase algorithm. So just imagine Al Gore, doing stuff on stage. That's algorithm. If you think I'm bad, you have to take classes from Larry Dumas. And so I can see some people have taken his classes. Yep. You can probably write down like 20 quotable quotes every 10 minutes. All right, so what is an algorithm? An algorithm, you can look up that word, you can look it up in the dictionary. It's basically a procedure. Okay, in this class we're not too concerned about formula, but it's a procedure for solving a problem. Well, that's why we talked about what a problem is. Okay, a problem is basically expressed as a precondition, what we know prior to the execution of the program, and a post-condition, which is what we want at the end of the execution of the program. An algorithm is the procedure. It's the stuff in between that the computer has to do to get to the post-condition. Okay, that's an algorithm. It's just a procedure. It's just steps, a sequence of steps. That's about the end of this particular slide. So an algorithm is, if you want to look at it this way, it's just a fancy word for method. Okay, how do we do something? That is an algorithm. In this class, we only use pseudocode. In other words, I do not use C or C++ or Pascal or Visual Basic or any actual real programming language. I use pseudocode. What is pseudo? What does it mean? Go ahead.
Fake.
Fake, not real. Okay. Give me an example, 2 examples of using that word pseudo in phrases and words that we use. Yep.
Pseudonym?
Pseudonym, which means it's a fake name, right? Okay, go ahead.
I was going to say D&D, a pseudo dragon.
A pseudo dragon.
It's a creature in D&D that looks like a dragon, it's not a dragon.
Okay, so the key is not, right? Pseudo whatever is not whatever. But it looks kind of like whatever. There's some resemblance, but it's not. Okay? Let me test your biology. What is a pseudopod?
Not really a
It's not really a pod. Okay, very good.
It looks like it has feet, but it doesn't.
It looks like
It doesn't have true feet.
doesn't have true feet. Very good. So what animal has pseudopods? Snails, amoeba. Okay, amoebas move by extending, their stuff. Okay, so those are called pseudopods because they're not actual limbs. They're basically, they look like limbs, they function like limbs, but they're not actual limbs. So in this class, we use pseudocode, which means they look like program code. They have some resemblance, and they serve kind of the same purpose, but they're not actually code that you can run on the computer. Doesn't that sound like defeating the whole purpose of this class? At the end of this class, we do not end up with any skill whatsoever that we can actually use to program computers, or do we? What do you think? So why do we use pseudocode? What is the whole purpose of using pseudocode? Yep.
It's easily readable.
It's easily readable. Go ahead.
I was just gonna say, well, pretty much what you said for to get the general idea without confusing yourself with the complexity of your
With the
code.
syntax, with all the itty-bitty details, right? Where do I put the semicolon? You put it at the wrong place, a real programming language would just block at you and say, I don't know what you're talking about. But I just miss a semicolon at the end of the line. I don't know what you're talking about. Go back. Right? In pseudocode, I'm the one reading your code. If you miss a semicolon, or if you even forget to close parentheses, if it is at the end, I can kind of tell that you kind of missed one at the end. Okay, I can still understand, for the most part, what you're talking about. If you misspell the word and, A-N-D, okay, and you type it out as just A-N, okay, but from the context, I can probably guess that you mean the logical operation and, A-N-D. Okay, and there was another hand back there. You guys, no, you good? Okay. So that's why we use pseudocode. It's not really because I like pseudocode. It's because it is easier to write and easier to understand when the programs are not intended to actually be executed or run by a computer. But isn't that also defeating the whole purpose of this class? Don't we want the computers to run the programs in the end? And yet, that's not what we're going to do in this class. Why? Yep.
Like a prototype.
Like a prototype, okay.
It's a weird build, but just keep going at it.
Okay. That may be one of the reasons. Go ahead.
This class is about concepts.
It's about concepts. It's about you being able to figure out what a program is supposed to do. Okay? I don't want someone to tell me, oh, when I ask someone and say, okay, what does this program do? What does your program do? Okay? Because that person actually wrote the program. And the person said, well, I'll come back a little bit later, let me run the program first to figure out what it does. That's not a good sign. Okay? Because if you write a particular program, you should know what it does. Now, you may not be able to do it as quickly as a computer. That's fine, not a problem. But you should still be able to follow the very same instructions and tell me what it is going to do. What is the next step? What is the next step? What is the next step? You should be able to lead ahead of the execution of the program and tell me what the program is about to do. Is that okay? That's what I want you guys to be able to do. Is to tell me, if I give you a program, if I give you an algorithm, you have to tell me what it is going to do. Okay? Are there any questions about what I have just talked about? Because that's all rationale of why we use pseudocode in this class and not a particular programming language. Okay, so how do we actually run programs then? If we don't use computers to actually run the code, then what do we do? Well, I use traces. Okay, I will let you guys document what a program does as it executes. Okay, it's using a spreadsheet. I'll show you guys exactly what you need to do throughout the semester. At the beginning, it's really simple, and it gets more complicated, then it gets more complicated, and so on. Okay. All right. And we get to the last one, which is not really a question. This is really just a conclusion. It's a summary of all the terms that are introduced in this particular reading material. A problem is defined by a precondition and a postcondition. To solve a problem is to derive the formal steps, the algorithm, so that the computer can follow these steps to go from the precondition to the postcondition. An algorithm can be expressed in a variety of programming languages, but in this class I use pseudocode so that we don't have to deal with actual syntax as much as actual programming languages. So that's kind of a quick summary of what we have just talked about. Are there any questions before we move on? Okay, questions? All right. So we'll go ahead and move on to the next reading material. I have links here to Wikipedia for those of you who want to learn about what is a software developer, and also for people who want to learn about the word algorithm. I don't think it's really necessary, but for people who are curious, these two things can be kind of interesting to read. So we are now moving on to topic 2. In topic 2, we have a few things. Okay, we have 2 more reading material and interactive reading material. So let's go to the first one. This is what I like to see. About 47 people have done it, or at least there are 47 attempts, which means probably a few people did not do it. But this is a good ratio. Sometimes I only see like 20 with a class of this size. So less than half the people actually go ahead and read something that they're supposed to read. Remember, your answer here does not count to your final grade. There's no need to worry about, I don't want to do this because I might get it wrong. Okay, it's not a problem. Okay, it doesn't hook up to your actual score of this class. What if it is wrong? Is it a bad thing? No, it simply points out that your understanding of the material is not what it is intended. Is it your fault? No, it can be my fault of not explaining something correctly. It simply means there's a discrepancy. But knowing that there is a discrepancy is good, because it says, okay, what you're telling me is not what I am interpreting or understanding. Tell me what you intend when you say blah, blah, blah. Okay? So I can clarify. Okay? Remember, the score doesn't matter. It is not the point. Okay. So getting back to this part here. Values. What is a particular value? 4 is a value. Okay? It is a quantity. So at the beginning of this class, we'll just be dealing with numbers. Okay? Or I should say values that correspond to quantities of something. Okay? In this class, I'm not going to spend too much time to differentiate the concepts. What do you see on the whiteboard? 4 dots, right? Okay, that's a quantity. What is this? It's the number 4. What is that? That's the word 4. And I'm going to give you something that you will frown and go like, what is that? Okay, fine, It is the Chinese character for the concept, for the value 4. So what I want to do is to differentiate the quantity, which you can see, from the representation. This one, this one, this one. Those are representations of the same quantity. Why do we need representations? So you can communicate, right? So you can tell other people, how many blah, blah, blah did you book, okay? And you can just use a word. Okay, instead of bringing somebody to your house and say, okay, you want to know how many plants I have and how many tomato plants I have. If I don't have a word to represent the quantity, what do I have to do? I have to drag you to my house, to my backyard, and show you how many tomato plants I have. Okay, that's why we have representation. Okay, but getting back to here, is this the only way to represent the quantity 4 as a number? No. This is in base 10. As it turns out, there are other bases as well. There's base 2. Okay, base 2 is really useful because computers are binary for the most part, which means zeros and ones. So 100 as a base 2 number means exactly the same thing as 4 in base 10. Well, is that really such a important, such a different concept? Just think about currency. Okay, how much is a bag of rice worth? Okay, how many US dollars? Okay, but in this country we use US dollars. What about in Mexico? Peso, okay, different units, right? In Canada, Canadian dollar. In Great Britain, which does not consider itself a European country, pounds, right? The rest of Europe, euro. Russia.
The dog globe?
BMWs.
I don't know. Different units, right? But once again, we have different units to represent the same worth, right? If you go to a particular place where people do not use money, they might give you number of shells, right? They might give you chickens, okay? I will trade you one bag of rice with 2 chickens and a half, okay? But once again, it's a representation, okay? So at some point we're gonna get back to this, okay? But just not today, not right now. So 23 is, well, just pick one of these. Operators and expressions is just stuff that we have already used throughout our lives, okay? This is an operator, okay? It's a symbol for an operator. It's called an operator because it specifies some kind of operation, okay? In this case, it specifies the addition operation. And in an addition operation, in addition to the specification of what you are going to do, you also have to give it something to work on, something to operate on. So in this case, the expression 23 plus 56 is an expression, but it's a combination of not just the operator, which is the plus, but also the values. 23 is a value, 56 is a value. The operator plus is saying, okay, what am I going to do with these two values? Add them together. Okay? So once you add 23 to 56, what do you have? You have another value, the result of the addition. So let me see if I can still add here. So the answer is 79. 79 is the value of the expression itself. Are we doing okay so far with these concepts? Operators need something to work on, but after it works on those things, it gives you a value itself. So the addition operation gives you a value. Division gives you a value, and so on. Okay? So nothing really surprising, nothing that we really haven't seen before. The only thing I want to point out is because of the limitation of a keyboard, okay, let me just kind of magnify this a little bit. We don't really have the division symbol on the keyboard. You can type it in by various means, but it's really kind of cumbersome. In programming, we don't like cumbersome ways of doing things, so we just say, okay, slash is division. Okay? But it means a little more than that. Slash means the quotient of the division. Okay? It's not the actual result of the division, which can have like decimal places and whatnot. But when we specify 56 divided by 7 using a slash, we only care about the quotient of the division. In this case, it doesn't matter because it's divisible. But in other cases where it's not divisible, we only take the quotient of the division. We also do not have a multiplication symbol on the keyboard. You can kind of use a lowercase x to approximate that, but that's not good either. We use the symbol asterisk to represent multiplication. So when you see 6 asterisk 8, it means 6 times 8. So are there any questions about the use of symbols in computer science? This is pretty much universal. Yep, go
I
ahead.
just wanted to double check with the division when you say the quotient only, it would just be how many times it goes into that without the extra to revoke.
Without the remainder.
Okay, yeah, okay.
The remainder has its own operator.
Okay.
So when you look at the division, the 4 parts of a division this is called the dividend, the number that is being divided. This is the divisor, the number that divides the other one. This is the quotient, and this is the remainder.
Okay.
So when we use the slash, we only care about this portion, but not the remainder. All right, so moving on to the next one. Division clarified, which is basically just a repetition of what I said. The remainder uses the operator called mod, or sometimes we use a percent symbol. So I'm just going to give you an example here. 56 mod 5 is the remainder of 56 divided by 5, which is going to be a 1. 56 slash 5 is the quotient of 56 divided by 5, which is 11, exactly. Okay. So we don't really say it's 11.2, okay, because we are dealing with integer division, which only cares about the quotient. So there's a question of what is the quotient of 2 divided by 5. I'll let you guys work this out. Okay, now in just normal math, we also have priorities assigned to operators, which is really just kind of more or less convention. Programming languages usually follow the same convention. So when you see 2 plus 3 times 4, okay, the multiplication has higher priority, which means you perform that operation first. So 3 times 4 is 12, then you add the 2 to the 12, which means the final answer is 14. If you use a cheap calculator, it doesn't understand priority. So when you type in 2 plus 3 times 4 on a cheap calculator, it would actually do the addition first, give you the 5, and then use the 5 to multiply the 4, which gives you the answer of 20. That is not how we're going to do things in this class. We will use the conventional priority assignment. Okay. You can always use parentheses too. If you think that sometimes it's not clear which one should happen first, use parentheses. In other words, in this case, you are explicitly stating that 2 plus 3 has to be computed first. The sum of these two numbers is then used for the multiplication. So you can always use parentheses to specify, yes, do this first. Go ahead.
Sorry, could you please explain that example, the 56 mod 5? That was on the other page.
Okay, 56 mod 5 is the remainder of 56 divided by 5. Which means what I want to compute is this. 56 is my dividend. 5 is my divisor. 11 is my quotient. And 1 is my remainder.
Okay, so that question was asking you for the remainder.
Yeah, when you have the mod operator, it's asking you what is the remainder of a division. Sure. So in this class, we use the usual mathematical convention in decreasing priority. If you see multiplication, division, mod in either spelled out as mod or just a percent symbol, they have a higher priority. Plus and minus have a lower priority, which is basically the usual way of doing things. So this one is just really asking you to figure out the value of this expression, and I'm going to leave it up to you to do the computation. Yep.
I have a question about the mod operator.
Okay, go ahead.
So 56 divided by 5 is 11.2. So why are we putting 1? Are we
Because
using
it's a remainder.
integers?
Because we don't use the decimal points, because the answer itself, when we perform division, is called a integer division, so we don't really have a point to.
Right. So
We're not using floats in here then?
We are not using floating point. We are not using real numbers. So unless the question, or I specifically say that use real numbers, we're only dealing with integer numbers.
So we round up from 0.2 to
It's not quite rounding, it's really just the quotient after a division.
what other remainders could there be? Like if just any other remainder besides 1?
It's not the same thing as rounding.
Okay.
Go ahead.
Is there an operator that will display both the quotient and the remainder?
Nope. In most programming languages, there's no single operator to give you both results at the same time. The reason why that is the case is because the result of an operator can be consumed by another operator, right? But then you have to choose one. If you're providing two results out of one single operator, then which one is being used by the other higher level operator? So that's the problem, and we cannot specify two results from the same operation. All right. Any other questions? Those are all really good questions. Yep.
Is the mod and the percent sign function division only?
Is the percent or the mod operator?
Division only.
Yes, because only in division do we have a remainder. Because it means the remainder after division, so it is related to the process of division, but we throw away the quotient in this case, and we only get the remainder after the division. All right. So now we go to associativity, which means, when you have something like this, okay, they all have the same priority level because they're all multiplications and divisions. So the question is, okay, in this case, does it matter which way we go first? Okay, do I do the 2 times 2 first? Do I do the 8 divided by 2 first, or what not? So in this case, the associativity is basically saying, okay, if I have to put parentheses around these operations, how should I put parentheses to specify which one happens first? And most of the time, we use left associativity, which basically means this expression becomes this. We perform the multiplication, then we perform the division, and then we perform the multiplication again. Okay, because you can imagine that if you reorder these operations, the value of this expression is different from the value of this expression. So whether something is left associative or right associative is important. Is that okay? Left associative is the default, but there are operators in real programming languages that are right associative. Okay? We don't have to deal with those in this class, but in C and C++, you will have to encounter those things and know when to use left and when to use right. Okay, so I'll give you one little example here. I'll let you guys figure it out. Moving on to the next one. Oh, we're all done. Submit all and finish. And I think it does give me the result after a while. Okay. But since I skipped most of those things, I probably won't get a score. I get a score of 0 because I skipped. All right. So getting on to the next one. Let's see. The next one is also a reading material, and now we're starting to get into some actual programming stuff. So we will talk about, only 38. The last one had about 40-something people. This one only has 38. So there are quite a few people who have not tried this one out. Okay. See, this is how I can keep track of, how many people, I need to find out who did or did not read the material. Okay. And sometimes I may answer questions based on that information. Which means, if something is in the reading material clearly and someone is asking a question about that, I might refer that person back to the reading material. Okay, in programming, a value is what we call a transient, which means a value it has to be used immediately. So I'll give you an example. This is not a good way to. Okay, this is better because they belong together. So in this case, you can see that 2 plus 3 has a value of 5. But the value of 5 can only last as long as the multiplication. Once it is used by the multiplication operation, it's gone. Okay, the value of 5 is no longer stored anywhere on the computer. Same thing with 8 minus 4. 8 minus 4 will give you a value of 4, but that value is consumed right away by the multiplication operation. So when this whole thing is done, we only get a final result of 20. But then what happened to 2? What happened to 3? What happened to 5? What happened to 4? They're gone. They're not stored anywhere anymore. Okay. But sometimes you might want to store those values. Okay, because if you want to count something, hey, you need something to store the value that you're counting, so that next time when you get back to that portion of the code, you know that, oh, okay, I counted up to 4 last time, now it is 5. Okay, so you need to keep track of things. If you need to keep track of things in a program, you cannot rely on just values and operators and stuff like that. You need a new concept. You need something that can store a value, so you can retrieve the value later on and possibly change that value, in some other parts of the program. The concept that you need is called a variable. So this is what a variable is. It's a programming construct that can store a particular value. Okay? The stored value of a variable can be utilized, can be retrieved, just like any value in an expression. Okay? Just like 2 or 3, the value of a variable can be used in multiplication, division, mod, and so on. Furthermore, the value of a variable can be changed or updated, same thing, okay, just different words, during the execution of a program. Keep in mind that a variable can only store a single value at any particular time. If you update the value of a variable, the old value is overwritten by the new value, and the old value is gone. There's no way to go back in time and say, oh, before I changed this to a new value, what was the previous value? There's no way to retrieve it, okay? But through the use of mathematics and induction, basically mathematical operations, sometimes you can infer the previous value after an operation. We'll get to that in this semester. Are there any questions about variables? Okay, no questions. Moving on to the next slide. So now, we talk about assignment operation. An assignment operation is the most basic operation that you can do with variables. You can change it. You can change the value of a variable. Assignment operations in this class looks like this, okay? This is only for this class. All other classes will use a different way to represent it, but I'm not going to use the other representation. In this class, I use the name of the variable on the left-hand side, a left arrow as the symbol for assignment itself, and then the right-hand side specifies the new value that you want to use to update the variable. So that's the way I represent assignment in this class. Many of you have some exposure to programming from some other sources, and you say, yeah, but all other classes use an equal to represent assignment. In other words, in a real programming language, they use this way to represent the same thing as what I use, x left arrow 3. So the question is, why am I so picky, and why am I so, stuck on using a left arrow instead of equal? Well, x equals to 3 can mean different things. One thing it can mean is asking the question. It's not even a statement. It's asking you, is x equals to 3 true or false? It's a comparison. So how can you tell whether this is a comparison as opposed to I am intending to change variable x so that its new value is 3? How can you tell? You can tell by the context, okay? In Visual Basic and other programming languages that make use of as x equals 3, they use the context to indicate, is this a comparison or is this really an update? It uses the context. But in this class, I don't want anything like that. Okay, I want to avoid confusion altogether, so I use a left arrow to mean that we are updating that guy. Yep.
Any reason why left instead of right?
Because that's how the information flows. You evaluate the right-hand side first, and then you use it to update the left-hand side. Does that work? Okay. Yep.
You've seen this before, but there's like 2 equal sign.
Aha! 2 equal sign. I was trying to avoid that topic altogether, but since you bring it up, I blame it on you. Okay. So in C++ and C and other languages derived from C, which is a whole bunch, when you want comparison, you use equal, equal. When you want assignment or changing, you use a single equal. But Ted, you just said something about the context will tell us whether it's an assignment or a comparison. Yes, that is true, but only in non-C, C++ based languages. Because in C and C++, you can embed an assignment inside a general expression, which makes your code really hard to read, and it's very easy to make a mistake and not know it because it looks right, okay? And I'm not going to bring it up in this class because it would just kind of cause more confusion, but in C and C++, I will tell you this much, okay? In CISP360, make sure you understand what is a single equal as opposed to a double equal. They are completely different, even though visually they resemble each other. If you use one instead of the other one, it is not necessarily a syntax error. In fact, in most cases, it's not. So the compiler won't catch it. It simply won't do what you think it is supposed to do. And those bugs are nasty because they can be very difficult to find. Okay? Any questions about that? I'm not going to get any further in this class because that's the whole idea of using a left arrow and not an equal. Okay? All right. So that's basically the whole idea here. So when you have an assignment operation, there are three parts to it. The left arrow itself simply is a separator, separating the left-hand side, which is specifying what am I updating, and the right-hand side, which is this is the new value of that thing. So the left-hand side has to be a variable. The right-hand side is just a value, something that evaluates to a single value, so you can use that value to update the left-hand side. Okay? And the order of evaluation, well, you already know, follow the arrow. Evaluate the right-hand side first. Whatever the value is, use it to update the left-hand side. Sounds pretty simple. Sequence of assignment operation. So this is how I usually write code in this class. I would use line number on one side, and then I will specify on that line what is the actual code on that line. So everything has a line number. So this way I can refer to the line number and say, oh, look at line 2. What is the effect of line 2? So I can actually refer to it. So in this case, let's take a look at what is happening here. Okay, so right now we're going to track everything in our head. Okay, we'll track the values of all the variables. So before we execute line 1, there should be one question. It's like, so what is x before line 1?
Undefined.
Okay, there's a difference between nothing as opposed to unknown. Okay, what is the difference between unknown versus nothing? What's in the trash can? Unknown is the right answer because there is something in there. You just don't know what it is. If you say there's nothing in it, that by itself is an assertion. You're basically saying it's empty. There's nothing in it. Okay, so unknown is the correct answer. Yes, go ahead.
But in almost all programs, when you reset it, at least if it's well written, it'll reset to 0.
There's no automatic reset in the case of C and C++. Everything starts with a value. You just don't know what it is.
Depends on how the things are.
I'll give you an example. Okay, a variable is nothing more than a bunch of zeros and ones. The location of a bunch of zeros and ones in memory. Okay, so when I just say, oh, you know what, variable x is these 4 bytes. This bunch of zeros and ones in the computer's memory. What exactly are in that location? What are the specific zeros and ones at those locations? We don't know. We know where it is, but we don't know what is at that location because it can be anything. It depends on which program ran before this one. Depends on how the operating system wants to allocate memory to you. Depends on a lot of things. Depends on, when you have a virtual memory system, it depends on what used to run at this place. Okay, there are many factors that can control the initial state of a particular variable. Well, do you care? No, I don't really care because as a good programming practice, you always initialize variables before you use it. You do not make assumptions and say, oh, it should be initialized to 0. because most programming languages would initialize to 0. No, do not make that assumption. Not in C or C++. Okay, you always say a variable starts with an unknown value until you initialize it with a known value, which is what line 1 is doing. Line 1 is saying, I don't care what x had before this point, now it is 4. Okay? Line 2 makes use of the value of x, but since line 2 is after line 1, I already know that x has a value of 4 at this point. So x times 3 is now the same as 4 times 3, which is 12. Then I use the value of 12, which is the right-hand side, to update the left-hand side. So variable y now has a value of 12. What is the value of y before line 2? I don't know, and I don't care. It is not important to me. Is that okay? What about line 3? Line 3 is saying x is again updated, but this time it is using the value of y to update it. What is the value of y again? 12. So now x becomes 12 as well. So that's the behavior of these 3 lines of code. Are there any questions related to these 3 lines of code? No questions? This is all good? Okay. All right, so we are moving on to the next one. The next one is a little bit confusing. What if we have the same variable, in this case x, appearing on the right-hand side and also on the left-hand side? Isn't this kind of cyclic? Because the moment I change x, it's going to change the value of the right-hand side. Then I have to do it all over again? Nope, it's a one-shot deal. Okay? When I say one-shot deal, I mean when you see something like this, x gets x plus 1, you evaluate the right-hand side first, but once. In other words, you take whatever value x has right at that time, you add 1 to it, it becomes the value of the right-hand side. Then it becomes just a value. Okay? It's no longer linked to x, it's just a value. Then you use the value of the right-hand side to update the variable on the left-hand side. The fact that the variable on the left-hand side was also what you used earlier to compute the right-hand side is irrelevant. Is that okay? So it's a one-shot deal, evaluate the right-hand side, come up with a value, update the left-hand side, you're done, move on. Okay? So there's nothing cyclic about this particular statement all by itself. Now, if you stick this in a loop, as we will see later in the semester, then you have a cyclic thing going on because you have a loop. But by itself, as an assignment statement, it is not cyclic in any way. Yep.
So can you give x a value and then tell me?
Right now, I cannot. This cannot be evaluated because I didn't tell you what x is, so there's no way I can tell you what x plus 1 is.
But let's say,
An example.
Yeah, can I say if x was 2, then the right side would just be 3 and the left would still be 2?
Well, we have an example here.
Okay.
Okay, so we have an example here. Okay, so the title of the example is right-hand side with left-hand side variable. In other words, x on line 2 appears on both the right-hand side and the left-hand side. So let's kind of go through this code just mentally first, and then we'll talk about how to express it on in the document. Before line 1, we know x is uninitialized. It has some kind of value, we just don't know what it is. Can be -1, can be 0, can be 2013, can be -4,000. I don't know what it is. It doesn't even matter because the first thing I do in this code is to override it with a known value of 3 on line 1. So the end result of line 1 is x ends up with the value of 3. So by the time we get to line 2, how do we evaluate line 2? What do we do first?
Right.
The right-hand side. So when we evaluate the right-hand side on line 2, x has a value of 3. 3 plus 1 is 4. Okay, just stick with the value of 4. At that point, you don't even need to know that the value of 4 is computed because of the value of x. You just stick with 4. What do we do with 4? Update x. So x becomes 4. Done with line 2. Move on. Is that answering the question? Okay. Very good. Yep.
If you have an assignment with multiple operators, does it read left to right of the right-hand side and then flow to the left?
Correct. The entire right-hand side is evaluated as one single expression. So that's when the priority and the associativity comes in play. But once it's evaluated, it becomes just one single value. And that is what you use to update the left-hand side. And in this class, we're not going to have multiple updates on the left-hand side, so you only update one variable at a time. In C, you can actually do that, which can also be confusing, but in this class, we're not going to do that. Okay. So in a way, I'm preparing you guys for cisp300 in C and C++, but in many other ways, I'm avoiding all the confusing parts of C and C++ because I want you to focus on the more important stuff, which is the logic of a program, not the obscurity of C and C++. For those of you who want to understand the extent of the obscurity of C and C++, you just have to go to Amazon and find a book. It's called Leave a Rope Long Enough, Shoot Yourself, C, C++, that should find it. There we go. This is actually the title of a book that tells you all the things that are obscure about C and C++. Enough rope to shoot yourself in the foot for C and C++ programming. Why would anyone write a book with that title? Because a lot of people shoot themselves in the foot with C and C++. Now that is also for a good reason. Since we are on this topic, I'm going to digress a little bit, just explain why that is the case. You don't see a book like this for Visual Basic. You don't see a book like this for COBOL. But this is kind of specific to C and C++. Why is that the case? Who came up with C and C++ with all these dangerous stuff that people can do? Okay, so you just look up C and C++. Okay, and you go to Wikipedia. And it's made by Strostrup. Okay, I actually met the guy once. He's okay. Okay, but he didn't come up with all these obscurity. Okay, the person who came up with C came up with all these obscurity stuff. So let's dig a little bit deeper. Okay, so we go to, instead of C, we go to C. Instead of C++, we go to C. So we click on C, and this is the textbook. The traditional textbook for C and C++, and this is the guy. Okay, if you want to blame someone for that textbook, this is the guy. But you can also blame him for all the wonderful stuff that we have. Okay, when did Steve Jobs die? When did he pass away? Just look at the date here, October 12, 2011. What about Steve Jobs? You guys have no curiosity. Come on. Steve Jobs. Okay, go to Wikipedia and just compare the date. October 5th, 2011, October 12th, 2011. I'm pretty sure most of you still remember when Steve Jobs passed away. It was a big thing. The media played it really big. Did you guys remember this guy who passed away just 1 week after Jobs?
Well, we're not going to remember Steve Wozniak either, so.
Well, he's still around. Wozniak is still around. And Wozniak is responsible for Apple II, which actually helped Apple took off. But after that, he worked on the Apple III, and that was not very successful. It just kind of left, not to do much about Apple anymore. But nobody remembered this guy. And why would he be important? I mean, after all, this is the guy who invented the C programming language, which is dangerous to use, a prompted textbook with that title that we just talked about. What is his contribution? I mean, he doesn't even look cool. I mean, Jobs, at least, it looks cool all the way to the end, right? Just compare and contrast this that is that. Just think about it. I mean, what is this guy? But he's an old guy who seems a little bit, who's thinking. Okay, he seems like he's thinking about something. So why is he important? But he invented the C programming language. But why did he invent the C programming language?
Not for like your general use.
No, it's not for general use. Go ahead.
Give you enough rope to shoot yourself in the foot.
Well, he gave himself a rope to do something useful. Okay? It was not the intention to shoot yourself in the foot. He made a tool because he is the guy who wrote Unix. Unix, Linux, Unix, what's the difference? Why do we care? Without this guy, there wouldn't be any iOS. What is iOS?
It's on
Okay, sorry?
previous.
It's the operating system of iPhone, iPads, and so on. Mac OS X is also based on Unix. Okay, so without Unix, you would not have Mac OS X. You would not have iOS. Yep.
Then he made it difficult so that other people couldn't.
Nope, that was not his intention. When he wrote the operating system, Unix, okay, which is a fairly complex chunk of code, okay, he was writing everything in assembly language. Now, most of you, obviously, at this point, you would not know what is assembly programming language and why is it undesirable to write an entire program, an entire operating system using assembly language. So I'll give you an analogy. You're at a beach, you want to build a castle. You cannot use clumps of sand. You have to use grains of sand, one by one, to make your sand castle. That is what it is like to write an operating system using assembly language. This is a smart guy. The guy said, this is boring. I don't like it. So what did he do? He made a tool. He made a tool to make it easier to write the operating system. Yep.
AOL was Unix based too. Can we blame him for that?
Well, there are other people along the way to be blamed. But he's the one who came up with Unix. And in the process of writing Unix, which is a fairly complex piece of software, he decided that I don't want to do it using the grains of sand approach. He wants to build tools so that he can become more effective. He invented the C programming language for himself and his partner. Okay, there's one more person who helped him wrote Unix as a tool. In other words, this is a very seasoned, experienced guru in programming. And he's making a tool for himself. He was making a tool for himself. It was never intended to be distributed other than within the lab, within Bell Labs. Okay? So, as a very experienced carpenter, do you think you need like 20 gazillion features so you won't accidentally cut off your finger? No. The electrical cord is just dangling somewhere. In fact, you just flip the big old switch. There's no switch on the saw itself. You plug it in and it's on. There's no guard of any kind. Okay? It's dangerous. But you know what? He doesn't mind. He's a very experienced programmer. Are you? Am I? Not as well as him. Okay? So when C and C++ became a de facto standard programming language on computers, it became also the instructional programming language. And that's when the problem happens. That's when you and I would use a programming language originally intended for guys like him to write our usual programs. Is that okay? You guys now understand why you need to be very careful when you use C and C++, because it has features that is very useful, convenient for guys like him. But if you don't know those features well enough, it can also be very dangerous in the sense that your program may read one way, but it will do something different because you have to really understand the syntax very well in order to use it. Okay, so I do want to give you some background because I don't want you to just kind of walk away thinking, oh, the next class is going to be awful. Why do we have to use C and C++? It has a reason. Okay. Just remember, without him, he will never take off. He would never have taken off. You would not have your iPads, iPhones, and stuff like that. So, yeah. So getting back to where we left off. So I do digression once in a while, like what I just did, but usually there's a reason to do it, because once you know the rationale, next time not next time, but next semester, when you take cisp300, you understand why you have to be careful. Okay. Well, hopefully you remember. Okay, so we're done with this one. This is your homework, not homework, but this is the question. You have to answer that one. Yep.
I have a question about the
Yep.
formatting for the tracer
Uh-huh.
for this. Do you want to format it as pre, line 1, line 2,
Yes.
line 3, and then post?
Yep.
Or
Yep, that's exactly how it is, but it's described in the next slide, hopefully. Tracing the values of variables. This is what we'll be doing for the entire semester. You guys will be sick and tired of spreadsheets at the end of this semester. But there's a good reason why we are doing that. Okay, so instead of reading through this stuff here, I am going to illustrate it. Okay, so this is a spreadsheet that you can actually download. It has an extension of ODS, which means you have to use Libreoffice to open it. In fact, it is a requirement that you have to do your homework using Libreoffice. I know Microsoft Office can open these documents, but you have to use Libreoffice. Yes?
I was going to say, OpenOffice, isn't LibreOffice just a fork of OpenOffice?
Yes, it is. It's a fork after Oracle took over, and a bunch of people left. So LibreOffice is basically the same thing as OpenOffice, which is the same thing as StarOffice, that's the original name of that program. So when you do your homework, you want to download and install LibreOffice. Okay, but no one told me that I have to spend money on software in this class. Well, it's free. There's no excuse. So just look up LibreOffice. The first one is the correct link, and just go ahead and download and install it. Yep, go ahead.
It said the due date was today at 1 p.m.
Yeah, I'm gonna change that.
Okay.
That's okay. Yeah, so we'll change the due date of the quote-unquote homework assignment. So you can download and install it on your own computer. But what if you want to do your homework at home, here, at work, and stuff like that? You have to have administrative right to install the software. Well, in that case, you can look for LibreOffice Portable. LibreOffice Portable. And with this, you can install it on the thumb drive. So install it on the thumb drive, take the thumb drive with you, okay? You can go to the main computer lab. If they don't have LibreOffice installed, no big deal. Plug in your thumb drive and start the application from your thumb drive. You go home, plug in your thumb drive, start it from the thumb drive. You go to work, same thing. Okay, so this is the best thing about portable software is it goes with you on a thumb drive. Yep.
There are Mac ports with this, right?
Yes. Okay. So the other page, has it depends on which browser, which operating system you go in as. Since I went in as Linux, it has the Linux version of the installer. If you go in, from Mac OS 10, it will give you the installer for Mac OS 10. Okay. Yep.
How about for Windows? I have this like on a small Linux computer, not really good for stuff that are serious. Does it have this for Windows?
Yes. If you sign in as Windows, it will give you the executable to install in Windows. So it is available for all popular platforms. Okay, there's no excuse that you guys cannot install it. Okay. All right. So getting back to here, because I do want to finish this slide, it's kind of important. So the first thing you do is you right-click on it and you say Save Link As, because if you don't do this, you won't be able to open it and edit it later. I'm just going to save it in the temp folder. You can save it to wherever you want to. And then you use LibreOffice. It's already installed on my live CD, so I just go to Office, go to LibreOffice, and you can open it from inside LibreOffice. This is the best way to do it, okay? So you just say Open File, then you specify the folder where you saved it, and you just click on this file, Open, and now we have it. You can use the zoom feature to zoom in, like that, okay? So now we want to trace this particular program line by line. And the way we do it, I spell out the standard in the reading material. I'm assuming all of you are reading it, okay? Or have read it and retain that, okay? But in this case, I'm just using, I'm done with it, okay? The trick to do this is you want to open up the algorithm on one side and open up the trace on the other side, and you want to display both at the same time. There's a trick to do this. You go to Window and you say New Window. What this does is it opens up a new window on the same document. So now I have two documents, or two windows on the same document. The first one, well, this is the opposite way of how I usually do things. So I'm gonna move this one the other way. So the normal way that I run this class is I would display the algorithm on the left-hand side. So I usually would also zoom in a little bit. Zoom, zoom, zoom. Here we go. Okay, so usually I would display the algorithm on one side, and then I would do the trace on the other side. These two are different sheets of the same document. Okay, they're in the same document. So the way I trace these algorithms is I will dedicate one column for line number to indicate which line am I tracing. Okay, so we'll have one line for this one. One column for each variable. In this particular program, we have two variables, one for x and one for y. If you look at one column, it is the history of a variable, how it gets updated throughout the execution of a program. If you look at a row, it is a slice of time. So we start with a line called pre, which is stating the precondition of everything. Most of the time, not all of the time, the variables are unknown. But occasionally, they start with specific values as initial values. In this case, x and y do not have any particular known value, so I use question mark to indicate that these values are unknown. Then we move on to line 1. After line 1, 3 gets into x, so as a result, x has a value of 3. So on each row, you are writing down the end result of executing that line, not the beginning state of that line. Yep.
Why isn't y's value question mark on line 1 as well?
On line 1, it is unknown because we haven't done anything with y yet.
So the question mark just, it keeps going as long as it's blank?
Correct. Okay. So you if you want to, you can keep filling it in with question marks, but that's really tedious. So that means, what I mean is, if you leave it blank like that, it simply means it has not changed from the line before.
Okay.
So this way we don't have to keep typing question mark and stuff like that. So we'll go through this. I know we are running out of time. On line 2, we evaluate x plus 1, but x already has a value of 3 at this point. 3 plus 1 is 4. We use 4 to update the left-hand side, so x ends up with a value of 4 in this case. On line 3, y gets x plus 1. Evaluate the right-hand side first. Now, this is important. X is already 4 at this point. It's no longer 3. So now we use a value of 4, add it to 1, add 1 to it, it becomes 5. We use 5 to update y, so y is updated to a value of 5. On line 4, we update x just based on the value of y. Y is now 5, so x becomes 5 on line 4. Don't forget this. At the end of the entire trace, you use post to basically say, this is the end of a trace. Okay, so that's the general format of how we trace algorithms in this class. And this is the only program you use to do your homework assignment. Okay? I will assign the homework assignment. Yep, go ahead.
So in post row, we just fill in 5 for x, 5 for y?
You don't have to fill it in because by implication, if a cell is blank, it means it has not changed from the previous line. So it is implicitly saying that x has a value of 5, y has a value of 5. So you don't have to fill it in. All right. Okay, so we are running out of time today. I will see you guys next Monday. Have a nice weekend. And when I have the assignment assigned, I will send you an email. Okay?
Sorry, can you keep that on?